Greetings, Earthlings. Today we're going to talk about Broadforks. This is a tool that is just commonplace in small-scale organic gardening these days. An excellent tool, an old-fashioned tool, really. I mean, these things date back several hundred years in both England and France. Both countries claim to be the origin of the Broadfork, but of course England and France are going to fight because they've done that for centuries. But anyway, just a nice, simple design tool for deep soil penetration and aeration without turning the soil over. Also a good root harvest tool to be used later in the year. In fact, I've dug all my sweet potatoes and white potatoes with one of these this year. Well, not all the white potatoes. I dug some of the white potatoes and I dug the rest with the walk-behind tractor. But for sweet potatoes, these things are great because nice long tines, nice wide penetration width, and plenty of leverage. And the root digger plow on the walk-behind tractor will not dig sweet potatoes. It just doesn't go deep enough because sweet potatoes are a root. They grow down and they can get a foot deep easy, and your root digger plow on the walk-behind tractor is just not going to go that deep. They'll get under white potatoes fine because white potatoes are a tuber, not a root. They don't go as deep. Regardless, Broadforks. So we've carried, since 2010, we've carried the Gullen Forge Broadforks. These are made by Larry Cooper, who runs a little business called Gullen Forge, which is very little. It's him in his garage. And he has a little forge set up. He's been a blacksmith for over 40 years. And he really knows what he's doing when it comes to building tools and metallurgy in general. Before we carried the Larry's Broadforks, we actually became a dealer for the Johnny's Broadforks made by Johnny's Tools, and they're decent. I figured, hey, Elliot Coleman helped design these things; they'll be all right. Well, one application in our Kentucky clay here, and we had a bunch of bent tines on the Johnny's fork. They're just not heavy enough to deal with the kind of clay soils that you have in the southern U.S. and in plenty of northern places in the U.S. too. And the fact is that clay is the kind of the predominant soil type for most of the U.S. And if you've got a heavy enough clay soil, you need a Broadfork that will hold up to that. So there are lots of different Broadforks on the market now. You've got the Meadow Creature and the Johnny's Broadforks, of course, the, is it Iron and Oak? I can't remember, there's so many different brands now. And of course there's a bunch of Chinese knockoffs, which are true garbage. But of the reputable Broadforks, we found that the Gullen Forge is the lightest Broadfork in the market that's actually built strong enough to hold up in clay soils. So while you wouldn't necessarily need the beefiness of this tool for working in sand or loamy soils, if you do get into clay, at least you're guaranteed you're not going to wreck the thing. Unless you're using it wrong, like to pry big tree roots out of the ground, or try to pry big boulders out of the ground. They're not made for that. They're not a digging bar. This is a soil working tool for gardening. So I've got the standard Gullen Broadfork here, which we've sold for years. This is the 17-inch tine to tine. That was the first size that Larry introduced. Eventually, he also built one that was an 18-inch wide tine to tine, still a 5-tine fork, just like added a 1/4 inch between tines, and extended those tines. I don't have one of those with me today, but you can picture this fork just with 2-inch longer tines and just a hair wider. That was the Big Bertha, we called it, for nearly a foot penetration. It's 11.5-inch penetration. This one is 9.5 inches, which matches the Johnny's Broadforks. The 9.5 inches is a nice depth because it goes deeper than any rototiller. Rototillers get to a maximum of 8 inches, and of course rototillers are very bad about causing a hard pan, so you need to get a little deeper than that to break up that pan. 9.5 does it nicely. For people who want to just get that extra depth, we offer the 11.5-inch tine, and you can get a little deeper yet. Not recommended for clay necessarily because I'm 160 pounds and I cannot get an 11.5-inch fork all the way buried into the ground in clay soil. I'm just not heavy enough. Now maybe if I weighed 200, I'd eat more oats, I guess, or something. So what makes the Gullen Fork Broadfork better? What we've found is that the tine diameter, being a little heavier, gives it a stronger tine, of course, but it's much more than just brute, you know, steel diameter. You can compare that to this one here. This is one of the BCS brand Broadforks. BCS actually has these made by the Tine company in Canada. It's essentially a knockoff of the Johnny's fork. They're extremely similar. But you can see the tine diameter. This is a 1/2 inch diameter. These are like 10 millimeters, so it's considerably smaller. No gussets on these tines. This is just a straight round tine that's been machine bent, put in a tool or like a tubing bender and bent like that. These actually have reinforcement gussets welded in here, so the beam strength of this, if you try to bend this tine back, when you bury this fork in the ground and they're pulling back on it, this is your pinch point here. This is where it's going to bend if it's going to bend. Same here, you're going to bend it right in here. There's no reinforcement in here to keep it from being bent. With the reinforcement gusset here, it about triples the strength of this tine. So there's just no way to bend these things unless, like I say, you're prying boulders out of the ground or something like this. But the tines themselves on Larry's forks, on the Gullen forks, are round, because round is a good shape to cut through to poke holes in the soil and be able to lift the soil more effectively. There's some forks on the market that use a tine where the entire tine is made out of a material like these gussets, just a flat steel. So it's just like a blade oriented this way. And the beam strength of those tines is very great because the top widens out like a gusset like this. So it's basically impossible to bend those tines. The problem is that you just have blades. So what happens is if your soil is a lighter soil at all, that is if you have a little more of a loam soil and you try to pull back on it, instead of lifting all that soil, it just cuts a bunch of slots through the soil. And you don't actually lift all the soil between the tines. Having a round tine lets you, get enough surface area on the front of those that you can still pick them up. Now, of course, you would think, okay, why don't they just make the tines flat like this way, where they can go down and, push into the ground and then lift like this, like a digging fork. Most digging fork tines are made that way. Well, that's okay, but then you don't have any beam strength. When you orient steel this way rather than this way, it's going to bend real easy because the thin part is here and the thick part is here, so that doesn't have any strength. And round is just a good shape that works with soil. This is why earthworms are round. If you ever see a square earthworm, let me know. So the combination of the round tine to be able to pick up a little more material and the flat steel gusset here is kind of the ultimate combination between the two, is what we find. To have a tine that penetrates the ground relatively easily, picks up the soil, is strong enough to hold up, and the extra resistance of pushing this narrow bit of blade in at the top of the, once this has actually penetrated the ground and made an opening, the extra effort to get this little bit of blade into the ground is not that much greater. So again, this seems to be the best of both worlds. So another thing that we've admired about the Gullen Forge Broadforks, since it's the only one on the market that's actually made by a blacksmith and not just some welding shop, is Larry takes the time to forge symmetrical points on these things. So that means that he hammers all four sides of the tip of this metal, gets it red hot in his forge and actually hammers it down so all four sides taper down to the point. And what that means is, as the point penetrates the ground, the soil is pushed off in all four different directions. It's opened up this way, all the way around symmetrically, rather than just pushing the soil all off to one side, which when you have a fork that's just machine created, that's what you typically get. They just cut these things off at an angle because it's the cheapest way to do it. Yes, it's still a point, but as this goes into the ground, it's pushing all the soil out of the way in one direction. So that actually leads to a little more resistance going into the ground. Instead of going like this, it's going like this and shoving all that soil to one side. So the penetration effort difference is not that much. It might be a few percentage points, depending on the soil type. But the point is, when you're making 1,000 stabs a day with the Broadfork, it adds up. So, the cumulative effort that you've made over the day just wears you out faster because you're having to do more work to get the fork into the ground. So Larry thought of that. He says, this is the way it means to be. There it is. He takes the extra time to do it. The other thing that's different about the Gullen Forge forks is a continuously curved tine. Something you don't find on any machine-made broad fork. Larry takes the time when he's got these things red hot in the forge, he puts them on a form and actually beats them into this perfectly round shape, a continuous curve. So that once the hole is made in the soil, the tine just flows into that hole in the same rotation. So basically when you're using a fork like this, you start with your hands forward like this, and then as you push it into the ground, as you get up on it and step it into the ground, the curvature of the tines will basically straighten up the handles. So by the time this is fully buried in the soil and this crossbar comes up against the ground, the tine handles will be, the fork handles will be straight up, and then you rock it back to crack the soil. So when you have, again, that continuous curve means that that one penetration hole is made and then the whole tine flows into that same hole. Reduces the effort very slightly, a few percentage points. Now this particular fork, the Tine fork sold by BCS, just is straight. So they just deal with that problem by going straight into the ground. It's, they're slightly offset to the handles, but essentially you're just pushing the thing straight into the ground. It's okay, but it doesn't have the same cup effect that a curved tine has to kind of pick up that soil like a scoop. But at least this enters the ground with relatively minimal effort because you're not, it's going in the same hole. The only problem with this is obviously the machine cut at the bottom, which is pushing that soil all off to one side. Now the Johnny's forks and some of the others, what they do is they bring their tine down straight and then bend it about midway. So it has an elbow in it, essentially like this. And that's the hardest of all of them to get into the ground because you're pushing an elbow around a corner. So all that soil around that elbow, just think if you had a curved pipe and you were trying to bend your elbow and fit through it. Well, it doesn't fit because if it's a true curved hole and you're trying to push something with an elbow through it, it's just going to hit here, here, and here. They're friction points. So that's kind of the worst tine design in terms of the effort necessary to get into the ground, is pushing something with a square elbow or even a 45-degree elbow down into a single penetration hole. That hole is going to look like an oval by the time that thing gets down all the way. So it has to push a bunch of soil aside that normally wouldn't have had to be displaced. So again, Larry takes the extra time to do that. Now, as I mentioned in the beginning, Larry has always made, or Gullen Forge, Larry, whatever, has always made forks that were a relatively narrow width, a 17 and 18-inch width, tine to tine. Got a lot of requests over the years for a 30-inch fork because a lot of people use 30-inch beds. And these narrower forks worked on a 30-inch bed. You just kind of had to make two passes. What I would do is go down one side and kind of come back the other side, kind of offsetting the stabs to go in between the others. Works fine. The nice thing about a lightweight fork, or a narrower fork like that, is it's a little lighter weight, a little more maneuverable, a little easier penetration because you're only pushing 5 tines into the ground. Now some people have said, well, why can't you make a 30-inch fork with 5 tines? Well, the spacings are so great between the tines that even in clay soils, it's not going to pick up all that soil in between. Too much stuff will just fall in between the tines and not be broken, cracked up. So you've got to keep that tine to tine spacing around the 4 to 5 inch range. 4 works about really the best for most soil types. So, so Larry finally this year, in 2025, made a 30-inch broad fork. So the problems with something like this, some are surmountable and some were not. One of the insurmountable problems is now we have 7 tines to push into the ground. So this is going to take more penetration effort. If you're using it in a 30-inch bed system where it's an established bed, you're working it every year, you're broad forking it every year, you're using a power harrow or some kind of tillage to loosen it up, you're probably going to be okay getting this into the ground in most soil types, even if you're fairly lightweight. It just depends on your soil. If you're in super high clay, like mine, I don't think I can use the 30-inch fork. It's just, with those extra 2 tines, that's 20% more penetration power I need, really 25%. And I just don't weigh that much, and my soil is very tight. I mean, I put compost and everything else on it every year, but it's still a very heavy clay. So for me, I'm gonna stick with the 5-tine. But if your soil is a little bit on the lighter side, you've done a better job getting the compost in there, put sand, whatever, to break it up, you can use this fork and save yourself some time, because now it's one penetration width for the entire 30-inch bed all the way down. So you're gonna have the time that it takes to broad fork your beds. So, like I say, the extra penetration pressure needed for the 7-tine fork is, there's nothing we can do about that. It's just, there's 7 tines on it. One thing Larry could change is the weight, because that was the other big question is, hey, if we use this type of construction and we make it this wide, it's just gonna weigh so much extra. Nobody's gonna wanna pick the thing up, because we know this has to be strong in order to hold up in clay soils. We don't want to chintz on the tines and the frame and things like that. I mean, look at this dinky little steel they use compared to the heavy steel we use here. Well, so what Larry did, since he has access to all different kinds of steel, he took this steel, which is the same outside dimension as this is a little thinner wall. He went to an alloy steel that has a thinner wall, but close to the same beam strength as the old one. This is just standard cold rolled. This is a little tougher steel. So that, going from a 1/4-inch wall thickness on this down to an 1/8-inch wall thickness on this really took off some weight. In fact, this 30-inch fork weighs the same as the old 18-inch wide fork that we had, the Big Bertha. So we stayed within that weight range, 18 pounds, and still have an incredibly strong fork here that you're not going to tear up no matter what kind of soil type you have. So good job, Larry. So another thing that Larry takes the time to do is directionally orient the wood. He uses ash handles. These are made in Tennessee by a handle manufacturer that Larry found years ago. Round tine, again, round is a nice, good, strong shape. That's why trees are round. A lot of other broadforks are using a square interface, that usually going to a round on the top because the round is a lot nicer to hold. This is it's just not as, it's close to the same dimension at the bottom, not quite as wide. I mean, the round has a little size advantage on it. But the biggest difference here is that, these are just machine cut handles. Well, they're all machine made handles. But the thing is, when they're cut square, nobody's taking the time to make sure that the wood is directionally oriented. The way a tree grows, it has rings, right? There's growth rings that come out. And when you cut that into boards, you've got a grain profile that you're gonna see within that board. The grain is gonna be going this way, your growth rings, or this way, or wherever part of the tree it was cut from, you're gonna have those growth rings in there. Well, just like I mentioned earlier, when you orient steel this way against a load versus this way is a lot stronger, right? Because you can't bend something that's like this. Growth rings in wood are the same way. If your growth rings are going this way in the board and you're trying to bend it this way, then you've got more strength, because those growth rings are like solid layers within there that don't want to bend, they don't want to break. If you orient it this way, kind of flat with the growth rings, and you put the pressure on this way, the wood's going to snap a lot easier. So when you make a square thing, you're just kind of at the mercy of wherever they cut the thing. And if you look at this, you can see that the growth rings in this are kind of sideways. So that's, or directionally orienting this handle when I put it in this square socket is essentially impossible. I want those growth rings to be this way, okay, compared to the fork, because that's where I want to put the fork. But I can't do it because the square keeps me from doing that. I've got to either choose this one or this one. So that both of them are going to be 45 degrees wrong. Here's another handle that's the same. Same deal. It's a 45 degree to where the force needs to actually be applied. Well, when you have a round handle, Larry looks at these things and he says, okay, my growth rings are going this way. That's where I'm going to drill my hole so that when I put it in here, it's going to be directionally oriented. So Larry figured that out years ago. Again, he's an old tool guy, so he knows these things need to be done. And, he has the choice of where to drill that hole because he's using a round socket. He can orient this thing whatever way it needs to go so that the growth rings are at their strongest point. And then he pre-drills the holes. He supplies stainless steel hardware, stainless steel lag bolt and washer. which there's a hole pre-drilled on the other side here. It goes right in there, bites into the wood, and so you never get rust. Not that the bolt would actually rust in there. Obviously, wood does not rust onto steel, but the point is, if this were just galvanized or unpainted or just untreated metal, eventually it would corrode within the wood, and if you ever had to replace the handle, there's more of a chance it would simply break off in there. The stainless steel is good forever, so it's just, you know, it costs them a couple extra bucks per fork, but it's the, you know, it's the best steel on the market, and it's never going to corrode. So the other nice thing about having a lag type bolt that's actually biting into the wood is it pulls the wood up solid against one side of this socket, so there's no rattle. I mean, if it starts rattling eventually, it's just because your lag bolt is loosened up and you can just tighten it right back up. Anything with a square socket, usually they have bolts that go all the way through and a nut on the other side, and that's a little bit of an issue because it's always going to rattle around in there a little bit. It doesn't, since the fastener is on both sides of the metal, a bolt going through with a nut on the other side, you just tighten that down, and you know, if you tighten it enough to actually crush the metal down to where the wood can't move, then you're going to have problems if you ever have to take it out, because this metal has now been crushed down against the wood on both sides, and you'll have to beat the thing out of there. You'll have to beat a new handle in because you've essentially deformed the socket. So this, you know, like I say, it's pulling it against the wood on one side, but once you loosen it, it releases the wood and you can pull it right back out. So some companies like Johnny's actually send their fork handles, they have square fork handles as well, and they use a wedge in the bottom to kind of spread it out against the inside of the steel before you put the bolt in. That works okay, but the wedges fall out and then the thing gets loose. So this we find to be just the most reliable handle interface. And yeah, I think that about covers it. Now you know why we carry the Gullen Forge Broadforks, and we've got them here for you when you're ready. Thanks for watching.